So now we need to get to this idea of how does this relate to Earth's plates, right? So we've been looking at how, with this idea of continental drift, that it appears that the continents were once together in the past, and now, they're not. Now there's an ocean in between them. So how is it that these plates actually moved? So that idea of the convection currents taking place in the mantle is a big deal, right? So we have the core of the Earth is transferring energy to the mantle, right? It's causing the mantle to kind of heat up in those certain areas. That hot mantle is going to rise, the cooler mantle is going to sink, and is creating those convection currents. Now, these demonstrations are going to start getting into the idea, okay, well, how does that relate to the plates actually moving? Because in my opinion, that's a big deal. So let's kind of see what they can show us.
Good morning. Here with us this morning we have a tank that's got some water in it. I've got some wooden blocks, one for Africa, one for South America. The wooden blocks, when I will place them in this tank, do not go past the little dividing barriers. Into this tank I'm going to place 2 bottles of ice water, just one on either side of the barriers so that they would stop there anyway. So right now we've got ice water. Into this container, what I'm going to do is I'm going to pour some hot water. That hot water is just under boiling. That's going to go in the middle here. There.
The only thing that kind of bothers me about this video is that it appears, because you can see the hot water rising, but these are supposed to represent the plates, right? So we can kind of see that they're being separated, but it kind of almost makes it look like it's being like pushed on the edges, which is kind of how it works. But we also have it being pushed from the bottom, and I have a different video to show you that. So this one's not bad, right? This is a pretty good video. You can see that. So if this is looking at being, the plates, and I don't want to say yes, the continents, but we know that the continents are part of the plates. So these ones are looking at being kind of the plates, and then this would be representing that hot mantle, or just kind of the mantle in general. I think there's some other videos that are better. This one's not too bad either. So let's go ahead and kind of look at this idea. This one uses candles instead for the heat transfer.
First we get the water and we pour it into the tray. We then get the 4 candles and we light them. Once the candles are lit, we carefully place them underneath the tray. Once our candles are under our tray, we get our 2 continents. Today we have Africa and South America. They are made from sponge. We get our 2 continents and we carefully place them in the tray of water next to one another.
Yeah, and with this one,
as the water heats up, we observe what happens.
Right, so you can see them moving, not so much apart right now, but they do move. Right, and that hot fluid rising is going to cause those to move. Rising and sinking is going to cause the continents, but more importantly, the plates to move. Because the continents are just part of the plates. Okay, this one doesn't quite show them moving apart. But I don't know if they kind of, there it goes. She kind of shows it here. Right, so they're kind of, in quotations, drifting apart, but really it's that hot mantle, or those convection currents in the mantle that are causing them to move. Right, really, so if you're looking in terms of energy transfers, well, it's the mantle transferring energy, those convection currents, and the mantle transferring energy to the plates to move on, which is kind of weird to think about because plates are huge. So it's pretty amazing that they have that much energy, like they can transfer that much energy to actually move plates. And this video is going to show, kind of explain it a little bit more. So you have things like the African plate. This one is kind of for a specific class. They're going to talk about how they've been talking about, these type of areas, we haven't talked about those yet. We've looked more just at the mid-ocean ridge, which this here is the mid-ocean ridge. Let's just kind of see what she has to say.
This video is intended to help you understand how the convection currents inside Earth's mantle work together to move the plates. This is the second part of the first essay quiz question for Chapter 5.
Ignore that part.
The map that you're looking at will help you understand because it is exactly the same area as your model. We were focusing on this area in your model right here. This circle would represent the circle on top of the model that we made in class. Let's focus on that as we look at how the plates are moving. The African plate is moving in this direction. The Arabian plate is moving in this direction here. So the Red Sea, which is here in the middle, is literally parting. And all of that is due to the convection currents that are in the mantle underneath that area. So under the crust, in that spot, you have a convection current going this direction and a convection current next to it going the other direction, which literally drives these two plates apart. They're resting on the soft asthenosphere.
You don't have to know that.
And they are pieces of the lithosphere.
You have to know
and
that
they
either.
are being pulled apart because of the convection currents that are running in this direction.
Right, and that's the most important thing for you guys to see too. Again, don't worry about the terminology of those, but really just seeing that, as that, you have the inner core, which is very hot. You have this transferring energy to the mantle. It's going to heat up those areas that, hot mantle is going to rise, the colder mantle is going to sink, and is going to create those convection currents, right? And then that's going to cause kind of these, and then these are going to transfer energy to the plates. I mean, you have the molecules in the mantle are in contact with the molecules in the plates, and they can actually move those plates, which again is pretty amazing to think about in terms of they can transfer that much energy to move these huge slabs.
And of course, those are going in a...
Okay, last video. I really like this one because it kind of puts everything together with what we've been doing in our class. So let me just go. So the beeping's kind of annoying. I apologize, but I can't really get rid of that. Come on. Maybe. If we're lucky. Why won't you play? It's like I was never gone today. Come on. Alright, let me see what is going on. Okay, I figured it out.
Are you sure this thing is rated for this depth? You bought it from an airmall catalog. Oh, great. Dear Tim and Moby, I look at a map. It seems like some continents fit together perfectly. Are my eyes playing tricks on me? From Georgia. You're not seeing things, Georgia. Some continents look exactly like puzzle pieces that snap together. Early map makers suspected that they were once all connected. In the early 20th century, a scientist named Alfred Wegener called this supercontinent Pangaea. He thought different chunks of it broke off and slowly moved apart. Over millions of years, they formed the continents we know today. Wegener couldn't explain why Pangaea split up or how. But there was some evidence to support his idea. Fossils from similar plants and animals have been found oceans apart. The age and type of rock layers matched up too. Wegener's theory of continental drift provided an explanation, but his ideas weren't taken seriously until long after he died. In the 1950s, scientists began mapping the Mid-Atlantic Ridge. It's a mountain range running 10,000 miles along the ocean floor. Tests revealed that the farther you got from the ridge, the older the seafloor was. So a geologist named Harry Hess proposed a revolutionary idea. New seafloor was forming at the ridge and